So applications of Kirchoff's laws. I think this is the second problem. Let us try to find out the current through each battery and then the current through 10 ohm and the potential drop across 10 ohm, all these things. And the problem is given so plainly like this. So nothing else is given. So no current direction, nothing. So what do we do when you face this kind of things? Assume first current directions. Let us say that this is positive, current is coming this way. If current is coming this way, current from this side also the same. Here battery, then current is coming this way, current is coming this way. So then suppose assuming that this current is I1, the current coming out of battery is I1 means current going into the battery is also I1. If current here is I2 means current here is also I2. And once this is done, just name the corners and junctions. Let us say A, B, C, D, E, F. After naming it, you can either choose to have loop in this direction or in this direction. That is your wish. There is nothing wrong in it. First, once this is done, this I2 is coming here, I1 is coming here. Let us say current through this is I3. If I3 means here from this current coming out is I3. Let us say I3 is coming this way. First apply junction law. So apply junction law at junction B. When you look at the junction, you will be able to get an important relation here. So the relation is I1 is toward the junction, I1 is toward the junction, I2 is toward the junction, I3 is away from the junction. So plus I1 plus I2 minus I3. So the net current at the junction is 0. This means that I1 plus I2 is equal to I3. In the previous problem, if there were 3 loops possible, we did all 3 loops. Now it is not necessary. So you can choose one loop here and one loop here. So you can choose this one loop and this one loop. Why I chose this was, there are 2 unknown variables, I1 and I2. I3 is nothing but sum of I1 and I2. So the 2 unknown variables are I1 and I2. So it's better to write only 2 equations to solve it. So first apply this loop. This loop C, B, E, D, C. So apply Kirchoff's voltage law for the loop. You can do either this way or this way. This is up to you. So let us say this way itself we will do, not this loop. So we will do in this direction. B, C, D, E, B for the loop B, C, D, E, B. So let us choose B to C. First on the left hand side it is summation of IR, on the right hand side it is summation of the EMF. If you and current are in the opposite directions negative and you and current are in the same directions positive, and if you go from negative to positive of the battery negative, positive to negative of the battery positive. Sorry, positive to negative of the battery negative, negative to positive of the battery positive. Okay, let's write that equation first. So BC. So you have to go as mentioned here, B to C, C to D, D to E, E to B. B to C, no IR. When you move from C to D, the current comes this way, you move in the opposite direction, I1 through 1. So it is minus I1 into 1. And D to E, there is nothing. E to B, when you come from E to B, this current is in this direction, you are coming in the opposite direction. So you and current are in the same direction because you are also moving from E to B, current is also moving from E to B, I2 through 2. So it is plus I2 into 2 is equal to EMF. B to C, no EMF. C to D, EMF is minus 3 because you are going from plus to minus, and then here D to E, no EMF. E to B, when you come, it is from minus to plus. So this EMF is minus 3, this EMF is plus 2. So minus 3 plus 2. So what are we getting now? So it is minus I1 plus 2I2 equal to minus 1. So let us keep this equation as 1, this as 2. Okay, let's try to write the third equation. In order to write the third equation, one more loop. Let us apply Kirchoff's voltage law for the loop A, B, E, F, A. So A, B, E, F, A. Okay, then A to B, on the left hand side IR, right hand side EMF. First look for IR. First go around once with IR. A to B, no resistance. B to E, the current comes in the opposite direction, I2 into 2. So it is minus I2 into 2. E to F, no resistor. F to A, you are coming in the opposite direction. So 10 ohm I3. So it is minus 10 I3 into 10. I3 into 10. Both are same only. Then EMF. So A to B, nothing. B to E, plus to minus. So it is minus 2. So you can rearrange. So it is minus 2 I2 minus I3 is actually I1 plus I2 from the first relation into 2 equal to minus 2. So it is 10 I2 minus 10 I2. So it is minus 12 I2 minus 10 I1 equal to minus 2. Let us change the relation. So 10 I1 plus 12 I2 equal to 2. And here let us have this, and this is a second equation. Let us have this equation 3. So let's do second equation into 10. What are we getting? 10 minus 10 I1 plus 20 I2 equal to minus 10. And let's have this 10 I1 plus 12 I2 equal to 2. When you add these two will be cancelled. So 32 I2 equal to minus 8. So here is a crunch. So I2 equal to minus 8 by 32, which is minus 1 by 4, which is 0.5. So sorry, 0.25. So it is, the current I2 is minus 0.25. Substituting current I2 in the second equation again. So it is second equation minus I1 plus 2 times I2 is minus 0.25 equal to minus 1. So minus I1 minus 0.5 equal to minus 1. Minus I1 is minus 1 plus 0.5 is minus 0.5. Then I1 is equal to 0.5. So I1 is plus 0 and I2 is minus 0.25. Then what about I3? I3 equal to I1 plus I2, that is equal to 0.5 minus 0.25. Plus of minus 0.25 is minus, so it is I3 is again 0.25 amperes. So all are in amperes now. See, let us look at the equation here. So we have got I2 as negative. That means what? Here we assumed the current I2 in this direction, but actually, so let us redraw the circuit here again. So this is the battery. So it is 10 ohms, and this is 1 ohm, and this is 2 ohm, and this is 3 volt, and this is 2 volt. We assumed I1 here, this is I1, this is I1, and this is I2. But you look at the sign of I1. I1 is plus. You assumed I1 already flowing in this direction. So I1 is this current. But that current is positive 0.5, means your assumed direction and the actual direction of current are same. But here you assumed I2 in this direction. You look at the graph here, I2 going in this direction. But your answer of I2 is minus. That means actually the current doesn't go in this direction, but the current goes in a direction opposite to it. So this is not the actual direction of current. The actual direction of current is this way. So that is why it is 0.25. So I1 0.5 comes toward the junction, 0.25 goes away, then the remaining current 0.25 ampere comes through this. Then what is the potential drop across 10 volt? The potential drop across 10 volt V10 equal to current into resistance. The current through 10 ohm is 0.25 and the resistance is 10 ohms. So 0.25 into 10 is 2.5 volt. So the potential drop across this 10 ohm resistor is 2.5 volt.